Okay, solving log equations. This is one of the simple kind. So we've got something which is written in power form. What we need to do first is write it in a log form. So remember, this is the base, this is the result, and this is the power. Rewriting it as a log equation, we get this. So log of the base 5 to get to 300 is x plus 1. Notice the only difference here from when we were solving them back in the very first videos is that the power was something a bit more complicated. This thing on the left hand side is something we can type into a calculator. So typing in log base 5 of 300 is literally just typing it into the equation. We get 3.54. So writing that down, 3.54 equals x plus 1. The last part of that is just solving for x. So x equals 2.54 and we're done. There's been rounding going on because this was non-exact. We get some sort of a rational number here. So this is rounded as well to 3 significant figures. Right, let's do a harder one. Now, this looks intimidating the first time you see it. It's really just a quadratic equation in disguise. This thing here, you can think of that as 3 to the x squared. So this bit is like we've got some sort of squared bit of 3 to the x. This bit is just a normal linear bit of 3 to the x. And then this is a constant at the end. If we did a little substitution of, say, y equals 3 to the x, then really all this equation is saying is 2 lots of y squared. This is 5 lots of y. And then this last bit is a negative 12. This thing here is a quadratic equation, so we could factorize it or we could use the formula. Let's go and factorize it. So 2y something, y and something, and then I think plus 4 and then minus 3, because that would give us the 8y in the middle, take away the 3y. Cool. Right, solving this, we get y equals 3 over 2, or y equals negative 4. The final thing to do here is to put it back into x's. We know what y is in terms of x, so each of these equations here we can write it as 3 to the x equals 3 over 2, or 3 to the x equals negative 4. Let's deal with this one first. There is no value of x that we can put into this which would make this true. Rearranging it as a log equation, we get log base 3 of negative 4 equals, well, if you stick that into your calculator, it will say math error. We can't put negative numbers inside. So this one's out. Fine. This one, rearranging it, log base 3 of 3 over 2. Well, that is something we can type into our calculator. I'll just do that off screen. And we get that. So 0.369. Since that was the only value of x which solved it, like this one didn't, then we are done. That is the only solution. Sometimes you get solutions from both of these branches. I've got some problems for you. Here you go. So as usual, pause the video, we'll go through the solutions in a minute. Okay, solutions. Let's talk about the first one first. So, the first one was the basic sort. We had 14 down as the base. We had 300 as the thing that goes inside the log, and then whatever the power was goes up here, 2x plus 1. The thing on the left hand side is something we can just type into a calculator, and it came out as about 2.16. When I did this, I just kept it on my calculator, so although I'm rounding it to 3 significant figures here, I'm keeping the answer on my calculator to do further steps. Taking away 1 and then dividing by 2, we get this bit here, 0.58. The second one, that was the quadratic equation. I've got to jump straight to factorising on this. This is like the quadratic bit because it's got the 2. This is the linear bit, this is the constant bit. So factorising, we get this thing here. And so solving for each of the branches, either 2 to the x equals 1 or 2 to the x equals 3. typing in log base 2 of 1 in your calculator gets you 0, but possibly you could see that it was going to be 0, because any time that you're getting something to the power of something and equaling 1, well, it's probably going to be a 0 here. This one here, what I've typed in is log base 2 of 3, and it gave me that, and I've rounded it to 3 significant figures. Right, time to do some from the book.